Hey team, we are now ready for week 5 of Trig Notes. So this week we will be continuing our Unit 3. We're actually going to finish up Unit 3, so we will be ready for the Unit 3 test on next week. Next week we will do the test and just a little short part of Unit 4. Unit 4 is like a breath of fresh air after this stuff, so be ready for that. So we're going to keep it on with our trig identities. These are our double angle formulas. So we're saying sine, cosine, and tangent of double an angle. We can simplify down to these things. You'll notice cosine actually has 3 choices, so that's fun. The one we use the most is cosine squared minus sine squared, so don't confuse that with the Pythagorean identity that's a plus. So if you have cosine squared minus sine squared, that's the same as cosine of 2 theta. Our sine of 2 theta is 2 sine cosine, and tangent is 2 tangent over 1 minus tangent squared. But also, tangent of 2 theta could be sine of 2 theta over cosine of 2 theta, which is usually a little bit easier if you have those. So let's try these guys out. Our example here says if the sine of theta is 5/13 and theta lies in quadrant 2, we want to find the exact value of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So first, sine of 2 theta, I need to find my cosine of just plain theta. So I know that y is 5, r is 13. So using x, y, r, I get x squared is 144. And so when I square root that, I get plus or minus 12. But since it's in quadrant 2, I know x is going to be negative 12. That means cosine of theta is negative 12/13, and tangent of theta is negative 5/12. That's going to give me everything I need to find these now. So sine of 2 theta is 2 times the sine of theta, which I know is 5/13, times the cosine of theta, which we just found is negative 12/13. So I can plug those in. I have 2 times 5/13 times negative 12/13. Multiply those together and you get negative 120 over 169. That's it. That's your answer for that one. Cosine of 2 theta. You can choose whichever formula you want. I'm just going to use that top one, cosine squared minus sine squared. So I know cosine is negative 12/13. Sine is 5/13. So I plug those in. And so I've got negative 12/13 squared minus 5/13 squared. So that's going to be a positive 12 squared is 144, 13 squared is 169, minus 5 squared is 25, 13 squared is 169. Subtract and you get 119 over 169. So the cosine of 2 theta is 119 over 169. The last one is tangent 2 theta. You can use your formula if you'd like. 2 times the tangent of theta we said was negative 5/12 over 1 minus negative 5/12 squared. So 2 times negative 5/12 is negative 10/12. Negative 5/12 squared is going to be a positive 25 over 144. 1 minus 25 over 144 is 119 over 144. Skip, flip, and multiply those. And 12 goes into 144 12 times. Negative 10 times 12 is negative 120 over 119. So that's my tangent of 2 theta. You'll notice if I put sine over cosine, your 169s will cancel and you'll get negative 120 over 119. So that is actually the easier way of finding tangent, but I wanted you to see how the formula works too. On to our next formulas. They are the half angle formulas. They're actually kind of the opposite of what we just did. So if we want to find the sine of an angle divided by 2, half of an angle, it's going to be plus or minus the square root of 1 minus the cosine of the angle over 2. Cosine of the half angle is almost the exact same thing, except it's a plus. And this time tangent has 3 choices. You could do these two things over each other, or you can do without the square root. Usually these two are easier. You have to kind of choose which one makes more sense. 1 minus cosine over sine, or sine over 1 plus cosine. So we use these a lot to find exact values, kind of like we did in the last week. So if I want to find the exact value of cosine of 112.5, I say, okay, that's not on the unit circle, but what if I take it times 2? In other words, what is this angle half of? So 112.5 is half of 225. So I could rewrite this as 225 divided by 2, and now it's a half angle formula. So that's going to be plus or minus square root of 1 plus cosine of that top angle, 225, over 2. So I look up my unit circle and I say, okay, what is cosine of 225? Well, it's negative square root of 2 over 3. Square root of 2 over 2. I can't even read my own writing, guys. God. So it's negative square root of 2 over 2. Well, I don't really like that fraction being in there, so I'm going to multiply everything times 2. So 1 times 2 is 2. 2 times that bottom 2 is going to cancel, and that's just minus square root of 2. And on the bottom, 2 times 2 is 4. And that's looking pretty good, but I need to decide, is it plus or is it minus? So I say, okay, what quadrant is 112.5 in? Well, I know it's bigger than 90, less than 180, so it's in quadrant 2. And in quadrant 2, cosine is negative. So my answer is negative square root of 2 minus square root of 2 over 4. And if you really want to be cool, you could square root that 4 and just put the square root on top and make it a 2 on the bottom. That would also work. There's more formulas. These look terrifying. They're actually some of the easiest ones to use. So what we're doing is we're taking two trig functions that are being multiplied and we're changing them into trig functions being added or subtracted. So they're called product to sum formulas. So there's sine times sine, cosine times cosine, sine times cosine, and cosine times sine. Whew. So what are we doing with these? You're going to have things that are being multiplied, and it's going to say express each of the following products as a sum or difference. So letter A, we have sine of 8x times sine of 3x. So we're going to use that sine times sine formula and just plug in. So there's a 1/2 out front, and then you do cosine of the first thing minus the second thing, minus cosine of the first thing plus the second thing. Just plug that in. And then we simplify. I know 8x minus 3x is 5x. 8x plus 3x is 11x. And that's your answer. You could distribute the 1/2 if you want and just make 1/2 cosine of each of those. But that's it. That's all you have to do. So letter B is similar, but now it's sine times cosine. So we use that sine times cosine formula, 1/2 out front, and it's sine of first thing plus second thing, so 4x plus x, plus sine of first thing minus second thing, so 4x minus x. So that's 1/2 of sine of 5x plus sine of 3x. Not so bad. We can also do the opposite. We can do sum to product. So if we're adding or subtracting, we can change them into multiplication. This time there's a 2 out front, and you're going to do like adding or subtracting over 2 in your sines and cosines over here. So let's try a couple of these. We want to express the sum or difference as a product. So letter A, we have sine of 9x plus sine of 5x. So we put our 2 out front, and then we have sine of first thing plus second thing over 2 times cosine of first thing minus second thing over 2. So 9x plus 5x is 14x. 9x minus 5x is 4x, and we can simplify this down a little more. 14x over 2 is 7x, 4x over 2 is 2x. One more of these, we have cosine of 4x minus cosine 3x, so that formula is a -2. Sine of first thing plus second thing over 2, sine of first thing minus second thing over 2. So -2 sine of 4x plus 3x is 7x over 2. 4x minus 3x is a 1x over 2, and those don't simplify. That's as good as that gets. So that's kind of how those work. We are going to do one last example of verifying the identity. So we want to verify that cosine of 3x minus cosine of 5x over sine of 3x plus sine of 5x is just tangent of x. So we start with that left side. And I know that I have a formula for just the top, cosine minus cosine. So I'm going to use my product to, or my sum to product. And then I'm going to do the same thing on the bottom. So if I look at the formula for cosine minus cosine, it's -2 sine of first thing plus second thing over 2, so 3x plus 5x over 2, times sine of first thing minus second thing over 2, 3x minus 5x over 2. Then the bottom one, sine plus sine, I'm going to use that formula. So it's 2 sine of first thing plus second thing over 2, cosine of first thing minus second thing over 2. So then when I look at this whole thing, there's a 2 on top and a 2 on bottom. They cancel. There's a sine of 3x plus 5x over 2 on the top and bottom. So those whole things cancel out. So I'm left with a negative sine of 3x minus 5x over 2. Well, 3x minus 5x is negative 2x over 2. And then cosine of negative 2x over 2. So my 2's are going to cancel inside there. So it's just an x. With sine, if there's a negative on the inside, it goes out front. So it's going to cancel that negative out front. With cosine, if there's a negative inside, it just goes away. So that leaves me with sine of x over cosine of x, which is tangent of x. That's what we wanted. So that's how you can verify those. So we're going to kind of put everything we've done in this unit together to solve trig equations. 3 kind of tips here. Use your algebra and trig facts. Try to factor stuff, try to simplify with trig identities where you can. Once you've done that, you want to get your trig function so that there's just one trig function equal to a value, like sine of x equals 0, or cosine of x equals square root of 2 over 2. And then you solve for your variable using your unit circle. So we're going to try a few of these and see how they go. So our first one, we want to solve 2 cosine squared x plus cosine x minus 1 equals 0. And you're going to see this on all of them. 0 is less than or equal to x is less than or equal to 2 pi. That just means all of your answers are on the unit circle. So when I look at this problem, it looks kind of like a quadratic. I have a squared and then a single one and then a number equals 0. So I'm going to factor this like a quadratic. So when I have 2 cosine squared x, I know I need 2 cosine x times cosine x, because when I multiply those together, that gives me that. And then I need factors of -1, or -1 and +1. I just have to decide where they go. So I put the -1 here because when I do outside 2 cosine times +1 and inside -1 times cosine, that's what's going to give me that plus cosine in the middle. So now that I'm factored, I can set each factor equal to 0. And then I'm going to solve these. So I add 1, I divide by 2, and I get cosine x equals 1/2. So I look at my unit circle and I say, okay, what x values, what cosines equal 1/2? And there are 2. At pi over 3 and 5 pi over 3, there are x values of 1/2. I go to my other equation, I subtract 1, and now that's by itself. Cosine x equals -1. So where on the unit circle is there a cosine, an x value of -1? There's only one, and that's at pi. So this equation has 3 answers: pi over 3, pi, and 5 pi over 3. So that's kind of how those work. We're going to try another one. This one's 2 cosine squared x plus 3 sine x equals 0. That's kind of gross because there's a cosine squared and a sine. It's hard to solve when there's different trig functions. So what I'm going to do is I'm going to change this cosine squared x into a sine. I'm going to use my Pythagorean identity and say, okay, I know sine squared plus cosine squared is 1, so I can rearrange that and say cosine squared x is the exact same thing as 1 minus sine squared x. So now I just need to solve this out. So I'm going to distribute the 2, and then I'm actually just going to move everything to the other side because I don't like having a negative sine squared. It's hard to factor when your squared term is negative. So I add everything or subtract everything over, and I have 2 sine squared x minus 3 sine x minus 2. So now I want to factor. So to get 2 sine squared x, that's going to be 2 sine times 1 sine. Factors of negative 2 are going to be negative 2 and positive 1. And then to get a negative 3, I'm going to put my negative 2 times my positive 2, and then my positive 1 to give me a negative 3. Set those equal to 0. So when 2 sine of x plus 1 equals 0, subtract your 1, divide by 2, sine of x equals negative 1/2. Find where on your unit circle do you have sines, y values of negative 1/2. There are 2 of those at 7 pi over 6 and 11 pi over 6. Sine of x minus 2 equals 0. Add your 2. There's nowhere on the unit circle where sine equals 2. It's actually impossible. Sine is never bigger than 1. So that's a no solution. So you'll have 2 answers to this, 7 pi over 6 and 11 pi over 6. Amber alert, guys. Sorry. All right. Cosine of 2x plus sine of x, 3 sine of x minus 2 equals 0. So cosine of 2x, that is not good to solve for. So we're going to use what we just learned, our double angle theorems. And I'm going to find, this is the one that has 3 choices. So we want to choose wisely, right? So I'm going to use the one that only has a sine value in it. So I'm going to change that to 1 minus 2 sine squared x. And then 3 sine x minus 2 equals 0. Combine your like terms. So I have negative 2 sine squared x plus 3 sine x, and then 1 minus 2 is negative 1. Again, I don't like factoring when there's a negative sine squared. So you can either think of it as dividing them all by a negative 1, moving them all to the other side, whatever works for you. Either way, I get 2 sine squared x minus 3 sine x plus 1. The only way to get 2 sine squared is a 2 sine and a 1 sine. The only factors of 1 are either 1 and 1 or negative 1 and negative 1. But to get a negative 3, it has to be negative 1 and negative 1. Set those equal to 0. So 2 sine x minus 1 equals 0. Add 1, divide by 2. Sine x equals 1/2. So where on the unit circle do we have sine values, y values of positive 1/2? At pi over 6 and 5 pi over 6. Sine of x minus 1 equals 0. Add 1. So where on the unit circle do we have sines, y values that equal 1? The only time that happens is at pi over 2. So we have 3 answers on this guy. Pi over 6, pi over 2, and 5 pi over 6. So that's it for this week. You are ready for your week 5 homework. Next week, we're going to do the Unit 3 test. I'll put the review up as well. And we're going to do just a few notes for Unit 4. Like I said, it's going to be way easier than this unit. It'll be a nice way to end things. Week 7 is just going to be the Unit 4 quiz or test, whatever I end up making it. So that's all we have left for Trig. So make sure you're getting caught up. Make sure you're feeling good about stuff. Keep working hard. Let me know if you need anything. Good job.